What color is light? Seriously. Look at your screen right now. What color do you see? White? Yellow? Blue? Here's the thing. Light has no color. None. That red apple on your kitchen counter? Not red. The blue sky above you? Not blue. The green grass outside? Not green. Color doesn't exist out there. It exists in here, inside your skull, nowhere else. Most people believe color is a property of light, that red light is genuinely, objectively red, that wavelengths carry color like trucks carry cargo. That belief is not a little wrong, fundamentally wrong. Here's a fact that should stop you cold. The entire visible spectrum, every sunset, every rainbow, every neon sign, is just a tiny slice of electromagnetic radiation. About 0.003% of all light that exists. And your brain takes that sliver and invents an entire world of color from nothing. Color is a hallucination. Your brain runs so consistently, you've mistaken it for reality. You've been seeing color your entire life. Every single day, every single moment, and not once has a color existed outside your head. This changes everything. How you see art, how you trust cameras, how you understand what seeing even means. Let me show you. Pick up your phone. No, really, do it right now. Look at your screen. See that white background? Those colorful app icons? Maybe a photo of someone you love? Here's your first lie of the day. Your phone screen cannot produce white light. It cannot produce orange. It cannot produce brown or pink or turquoise. Your phone only makes 3 colors: red, green, blue. That's it. Hold your screen close to your face. Closer. If you could zoom in far enough, you'd see thousands of tiny lights arranged in clusters. 3 lights per cluster. 1 red, 1 green, 1 blue. Nothing else. So where's that white coming from? Where's that sunset photo? Where's the yellow of that emoji? Your brain is inventing them. Right now. In real time. Here's the part nobody tells you. When red and green pixels light up together, there is no yellow light leaving your screen. 0 yellow photons. None. But you see yellow anyway. Your brain takes 2 wavelengths that have nothing to do with yellow and fabricates the experience of yellow from scratch. That's not a glitch. That's the system working exactly as designed. People say screens display colors, but that's just a label. Screens don't display colors. Screens trigger your brain into hallucinating colors. There's a difference. Think about what just happened. Every photo you've ever seen on a screen, every movie, every video call with your family, every memory you formed while looking at a display. None of those colors existed outside your skull. The universe sent wavelengths. Your brain made colors. And you thought you were seeing reality. Now watch what this implies. If your brain can invent yellow from red and green, 2 completely different wavelengths, then color isn't in the light at all. It can't be. Because the same experience of yellow can come from actual yellow wavelengths or from red plus green wavelengths that contain no yellow whatsoever. Same experience, different causes. That's not how reality works. That's how translation works. That's how interpretation works. That's how languages work. Color is not a property of light. Color is a language your brain speaks to itself. Wavelengths are just the raw data, meaningless until translated. And here's where it gets even stranger. Your brain doesn't even translate wavelengths accurately. It edits, it guesses, it lies. The universe keeps strict books on wavelengths. Your brain keeps sloppy books on color. And you've been trusting the sloppy books your entire life. Let's get inside your eye. Right now, light is flooding through your pupil. Millions of photons per second, each one carrying a specific wavelength, a number. That's all a wavelength is, a measurement, like height, like temperature. A photon with a wavelength of 650 nanometers hits your retina, another at 550, another at 450. These are just numbers, cold, objective, meaningless. But here's the trick. You don't have 650 nanometer detectors. You don't have 550 nanometer detectors. You have exactly 3 types of cone cells, just 3. One responds mostly to long wavelengths, one to medium, one to short. That's it. That's your entire color vision system. 3 sensors. Hold that thought. The visible spectrum contains millions of possible wavelengths, infinite technically. But your eye reduces all of that infinity down to 3 signals, 3 numbers sent to your brain. This is brutal compression. Imagine listening to a symphony orchestra, 100 instruments, thousands of frequencies, through a system that only reports 3 volumes, low, medium, high. You'd lose almost everything. Your eyes lose almost everything. And here's where your intuition fails. Your brain takes those 3 signals and constructs an entire universe of color. Thousands of shades, millions of combinations, from just 3 inputs. How? It guesses. Your brain runs a translation algorithm that converts 3 number combinations into color experiences. But here's the thing. That translation is completely arbitrary. There's no law of physics that says wavelength 650 should look red. No equation that outputs the experience of blue. People say certain wavelengths are certain colors, but that's just a label. The wavelength exists. The color is added by you. Let me say that again. The wavelength is real. The color is not. Red doesn't exist at 650 nanometers. Red exists in visual cortex, in neurons, in the hallucination your brain runs so smoothly you never notice it's happening. This is where it gets wild. Remember that yellow problem? Red light plus green light equals yellow experience? Here's why that happens. When 580 nanometer light hits your eye, it triggers your long wavelength cones a lot and your medium wavelength cones a lot. Your brain gets that signal pattern and invents yellow. But when red light and green light hit your eye together, same signal pattern. Long cones fire, medium cones fire. Same ratio. Your brain can't tell the difference, so it doesn't. It just calls both yellow and moves on. The universe keeps perfect books on wavelengths. Every photon tracked, every number exact. But your brain keeps rough books on color, approximations, shortcuts, guesses. Reality doesn't issue refunds on lost information. Once those wavelengths get compressed into 3 signals, the original data is gone forever. Your brain reconstructs something, but that something is invention, not detection. You're not seeing color, you're generating it. Your brain is a color-generating machine that uses wavelengths as suggestions, and you've confused the suggestions for the reality. So far we've learned, color doesn't exist in light, your phone proves it, and your eye's 3-sensor system forces your brain to guess. But if color is invented, who decided what the inventions should look like? England, 1666. A 23-year-old Isaac Newton sits in a darkened room. Cambridge is closed because of plague. He's bored. Dangerous combination, a genius with nothing to do. He cuts a small hole in his window shade. A beam of sunlight streams through. Then he does something nobody had done carefully before. He puts a glass prism in that beam, and the world changes. The white light spreads, fans out, becomes a rainbow stripe on his wall. Red on one end, violet on the other. Every shade in between. Now here's the part nobody tells you. Newton didn't discover that light contains colors. He discovered that light contains different wavelengths that bend differently through glass. That's it. That's all the prism showed. But Newton made a choice, a naming choice. He called them colors. He looked at the long wavelengths and wrote red. Looked at the short wavelengths and wrote violet. He created a vocabulary, a labeling system, and everyone just accepted it. This is the naming era that fooled the world. Newton was a physicist. He should have said, light contains wavelengths that refract at different angles. Cold, accurate, true. Instead, he said, white light contains all colors. Wrong. White light contains wavelengths. Human brains contain colors. Newton mixed up the territory and the map. Think about what just happened. The most influential scientist in history, the man who gave us gravity and calculus, he made a linguistic mistake about color, and 300 years later, we're still repeating it. People say white light is all colors combined, but that's just a label. White light is wavelengths combined. The white part happens in your skull when your three cone types fire equally. Newton's prism didn't separate colors, it separated wavelengths. The colors got added later, by you, by every observer who looked at that rainbow and experienced something. Here's where it gets even stranger. Newton actually argued with other scientists about this. Robert Hooke said colors were created by the interaction of light and matter, that color was relational, not absolute. Hooke was closer to right, but Newton had more clout, more fame, better publicist, basically. So Newton's naming convention won, and we've been stuck with it ever since. Doesn't matter how creative you are. Doesn't matter how hard you try. Your brain refuses. Now try something else. Imagine reddish green, not brown, not olive, not muddy yellow, pure red and pure green, simultaneously, in the same spot, reddish green. Impossible. Your brain won't do it, can't do it. The software doesn't allow it. This is where your intuition fails. If colors existed out in the world, truly, objectively, independently, why can't you imagine new ones? Why can't you combine certain ones? Because color isn't discovery, it's construction. And your brain's construction system has hard limits. Here's the trick. Your three cone types create what scientists call an opponent process system. Red versus green, blue versus yellow. Your brain processes these as opposites, mutually exclusive, one or the other. You can have reddish blue, that's violet, purple. You can have greenish blue, that's cyan, teal. But reddish green? The system crashes. Your brain literally cannot render that file. Hold that thought. If color existed in light, there would be no impossible combinations. You could mix any wavelengths and see the result. But you can't, because color isn't in the wavelengths. Color is in the processing. People say some colors clash, but that's just a label. Those colors don't clash out in the world. They clash in your neural wiring. Let me say that again. The impossibility of reddish green isn't physics. It's biology. It's the architecture of your visual cortex. It's the limitation of a three-sensor system running an opponent process algorithm. Color is a story your brain tells, and every story has rules, boundaries, things that can't happen. Reddish-green can't happen, not because light forbids it. Light doesn't care. Your brain forbids it. The universe keeps no books on color combinations. There's no cosmic law against reddish-green wavelengths mixing. But your brain keeps strict books. And in your brain's accounting system, some colors simply don't exist. Never have, never will. Pull out your phone again. Open your camera. Point it at something white, a wall, a piece of paper, a ceiling. Now look for the white balance setting. Every camera has one. Auto, daylight, tungsten, fluorescent, shade. Change it. Watch the entire image shift. Blues become yellows. Warm becomes cold. The same scene looks completely different. Here's the question. Which setting shows the true color? None of them. This is not a metaphor. Your camera doesn't see color. It has sensors, usually 3, just like your eyes. Red, green, blue. It captures wavelength data and then asks a simple question. What should I call white? That question has no correct answer. Here's the part nobody tells you. A white paper under candlelight reflects mostly long wavelengths, reddish. Under blue sky, it reflects shorter wavelengths, bluish. The physical light bouncing off that paper changes constantly, but you always see white paper. How? Your brain runs auto white balance non-stop, continuously, without asking permission. It looks at the scene, guesses the lighting conditions, and then subtracts that color from everything. You never see raw wavelengths, ever. You see corrected, adjusted, edited wavelengths. Your brain's interpretation of what things should look like. People say cameras capture colors, but that's just a label. Cameras capture wavelength data. Then software picks a fiction, a white point, a story about what the lighting really was. Different story, different colors. And here's where it gets even stranger. Professional photographers argue about white balance constantly. Film versus digital, daylight versus tungsten, which is correct. The universe doesn't care. Light doesn't negotiate with camera software. Wavelengths hit the sensor. Numbers get recorded. Everything after that is interpretation. Same with your eyes. The data coming in changes all day. Morning light, noon light, indoor light, screen light. But your brain constantly rewrites the story to keep colors stable. Reality doesn't issue refunds on ambiguity. When lighting conditions are unclear, your brain just picks something, commits to a fiction, and shows you that fiction as if it were fact. Your camera lies. Your brain lies. The only thing that doesn't lie? The wavelengths. And you never see those directly. There's a creature in the ocean that should make you question everything. The mantis shrimp. You have 3 types of color receptors. 3, that's it. The mantis shrimp has 16. 16 different cone types. 16 different wavelength sensors. Some of them detect ultraviolet light you can't even perceive. Some detect polarized light, things invisible to human eyes. So here's the obvious question. Does the mantis shrimp see more colors than you? Wrong. Scientists tested this carefully, rigorously. They showed mantis shrimp different colors and measured how well they could distinguish between them. The results were shocking. Mantis shrimp are actually worse at distinguishing similar colors than humans. With 16 receptors, they perform worse than you with 3. Wait, that makes no sense. More sensors should mean more colors, more detail, more richness, unless color isn't about sensors at all. Here's the trick. Your brain does heavy processing. It compares signals from your 3 cones, calculates ratios, runs opponent process algorithms. Your brain turns 3 inputs into millions of distinguishable colors through pure computational work. The mantis shrimp doesn't do that. Its brain barely compares signals. 16 receptors, almost no processing. It sees wavelengths more like a barcode scanner than an artist. Simple detection, minimal interpretation. Think about what this implies. Color richness isn't about hardware, it's about software. It's about what the brain does with the signals after they arrive. People say animals with more receptors see more, but that's just a label. Seeing isn't counting photons. Seeing is building an experience. And that building happens in neurons, not in eyeballs. The mantis shrimp proves it. More inputs, less color experience. Because color isn't in the inputs. Color is in the processing. Your brain is not a camera. It's not a wavelength detector. It's a storytelling machine. And 3 sensors plus heavy computation beats 16 sensors plus minimal computation. Every time. The universe keeps strict books on wavelengths. Every creature receives the same data. But what each creature does with that data? Completely different. Your color world is not the color world. It's just your brain's best guess. So far we've learned. Your phone fakes color with 3 lights. Your brain compresses infinite wavelengths into 3 signals. Newton mislabeled everything. Impossible colors prove the system has limits. Cameras choose fictions. And mantis shrimp prove more sensors don't mean more color. Now let's zoom out. What does this actually mean? Here's the deep truth. Perception is not detection. Perception is construction. You think seeing is passive. Light comes in. You observe it. Simple. Wrong. Seeing is active, creative, generative. Your brain takes incomplete data and builds a complete experience, fills gaps, makes assumptions, invents details. Color is just the most obvious example, but it's not the only one. Your brain constructs edges that don't exist, sharpens blurry images, stabilizes shaky vision, removes your blind spot, edits out your blood vessels. You've never seen raw reality. Not once. Not ever. Here's where it gets profound. If color is a language your brain speaks to itself, what else is? Pain? Maybe. Pain doesn't exist in your fingertip. It exists in your brain's interpretation of nerve signals. Same structure, same construction. Sound? Definitely. Air vibrations have no pitch, no tone, no music. Your brain invents all of that. Smell, taste, touch, all constructed, all invented, all languages your brain speaks to itself. Hold that thought. This isn't philosophy. This isn't mysticism. This is neuroscience. The universe contains wavelengths, vibrations, molecules, pressure waves, temperature gradients. The universe does not contain red, or middle C, or sweetness, or softness. Those are translations, human translations, languages that only exist inside skulls. Light doesn't negotiate with your experience. It delivers wavelengths, period. What you do with them is your business. And here's the beautiful part. This makes color more precious, not less. Color isn't cheap. Color isn't automatic. Color is a gift your brain creates fresh every millisecond. An ongoing hallucination so perfect, so consistent, so useful that you mistake it for the world. You are a color-generating machine walking through a colorless universe, painting everything you see, every moment, every day. The constant is enforced. Wavelengths remain wavelengths, but you transform them into sunsets, into faces, into art. The universe provides the data. You provide the experience. That's not a limitation. That's a superpower. Look around you, right now, whatever room you're in, whatever scene you see. Every color you're experiencing exists only inside your skull. The walls aren't colored. The objects aren't colored. The light isn't colored. You are colored. You are the source. Tomorrow morning when the sun rises, remember this. That orange glow on the horizon? Wavelengths. Just wavelengths. The orange happens in you. The beauty happens in you. The universe is running a silent film. You're adding the color in real time. Here's your final interactive moment. Tonight, look at a light source, any light. A lamp, a street light, a star. Ask yourself, what am I adding to this? The photons traveling millions of miles to reach your eye carry no color, none. The color you see is your contribution, your gift to the experience. Light is not colored, you are. And now you know. So here's my question for you. If color doesn't exist outside your brain, what else have you been projecting onto the universe and mistaking for reality? What else are you adding without knowing? Think about it. Then tell me in the comments, because I genuinely want to know what you'll never see the same way again.